going to look at absolute max and min in terms of word problems. These applications are called optimization, which optimization is just the study of optimizing things, trying to come up with the best, most optimized solution, absolute max and absolute min. So don't be alarmed when you see the word optimization. That's just the study of the absolute max and min. So we're going to have our exact same two steps, but now we'll have word problems. And I actually find that these word problems are typically easier to solve than some of the non-word problem questions. So looking at this first problem, we have a speaker company has total profit in dollars from manufacturing and selling X units of their Model A loudspeaker system is given by this P of X. So we have our profits, some good review of the formula for profit. How they calculated this is they did their revenue minus their cost. Just something to keep in mind, a formula that you should know. So they found their profit off of X loudspeakers is given by this function here. And they can make anywhere between 0 and 20,000 speakers. So we're, of course, not going to tell them, hey, you should make 50 billion speakers. You'll have a really good profit. They can only make between 0 and 20,000. And we want to figure out how many units of the loudspeaker system they should produce to maximize their profit and figure out what the maximum profit would be. So we're going to do our two steps. We're going to take the derivative first to find any critical numbers. So we're going to take p prime of x. And so we will find that by bringing down the power and subtracting 1 for the new power. So we have negative 0.02 times 2 is going to give us negative 0.04. Derivative of 300x is 300. So we have negative 0.04x plus 300 equals 0. Because that derivative of minus 200,000 is just going to be 0. It's a constant. So we take the derivative of the function, set it equal to 0. This one's nice and simple to solve. We don't have an x squared, which is why I like these word problems. We're just going to get x by itself by subtracting 300. And then we're going to divide both sides by this negative 0.04. So x is going to be negative 300 divided by negative 0.04, which is 7,500. Now remember, x stands for their loudspeakers. So our critical number is when they make 7,500 loudspeakers. Our second step is to either make a sign chart or ideally we'll be given an interval. So we know when we're talking about profit that the least amount of loudspeakers they can make is 0. And we're actually given this interval here. They can make anywhere between 0 and 20,000. So we're going to test 0 and we're going to test 20,000. It's probably not going to work out that they should make 0 speakers. That's not ideal for a company. But it may not necessarily be true that having 20,000 speakers produced is going to maximize their profit. So we're going to check the critical number as long as it's on the interval of interest, and this one is 7,500 is between 0 and 20,000. So we're going to test that. We're going to plug into the original function to compare these y values. So when you plug in 0 to the original function, you get negative 200,000. I need to grab my calculator and plug in 7,500. So negative 0.02 parentheses 7,500 squared plus 300 times 7,500 minus 200,000. I'm getting $925,000 in profit. And then I'm going to replace that x in the original function with a 20,000. So if they produce 20,000 speakers and we plug that into the original function, I'm getting negative 2,200,000. So what should we tell them to do? Do they want to make negative 200,000? Do they want to make 925,000? Or do they want negative 2.2 million? Well, our final suggestion would be that they should produce and sell. You have to sell to have profit, so they can't just produce it. They have to, put the effort in that they're doing with their sales. They should produce and sell 7,500 loudspeakers for an absolute max profit of $925,000. So you might be tempted to say, oh, well, they should just produce 20,000 because that's the most that they can. But remember this profit formula. It considers revenue. Revenue is based on the demand, the number of things that they're expected to sell times the price that they sell it for. So they have to have that demand work out to have a good revenue. And then they're also subtracting cost. And there is more cost to making more loudspeakers. So for them, it's not, oh, just make as many as you possibly can, for maybe two reasons. One, the cost could be too high to be making that many loudspeakers. They might have to employ people 24-hour shifts instead of just working a first shift type job or something like that. So they might have more staffing. They might have to have a bigger overhead cost for a bigger space. And also the revenue is something to consider. If there's not demand, there's no reason to be making that many. So I could make math is my favorite class t-shirts, but if y'all don't want to wear them, there's no point in making as many as I possibly can. So we have to consider both demand and the overhead costs when we're looking at profit. So it's not just make as many as possible and then you'll make the most money possible. It doesn't work like that because you have to consider demand and also the cost as well. So they should produce 7,500 because ideally if they sell those, they'll get their maximum profit.